Welcome. Good evening. I'm Deborah Crone, Chair of Academic Programs here at BGC, and I'm delighted to welcome so many friends and alums and other people. You're welcome to this final program of the academic year. And it's very fitting. It's a lecture that will be delivered by 2021 graduate of the PhD program, Julie Bellemare. On the way to her position now as curator of early modern glass at the Corning Museum of Glass, which she began shortly after finishing her PhD. She received a master's in the history of art and visual culture from the University of Oxford and holds a BA in art history and East Asian studies from McGill University. She's also held research positions at the Metropolitan Museum of Art, the National Museum of Asian Art, and the Brooklyn Museum, and has published widely on global decorative arts of the 18th century. In addition to her work on what she terms the polychrome revolution at the Qing court, she has written on the marketing of the Orient in England and France during the 17th and early 18th centuries, and blue and white porcelains, among many other topics. At Corning, she's responsible for stewarding, researching, and expanding the museum's collection of glass produced between 1250 and 1825. That's a pretty long early modern period. Last year, she curated an exhibition called Sensorium, Studies of Glass and Fragrance, which explored the millennia-long relationship between glass and scent, and was actually featured in a big article in the New York Times, which some of you may have seen. And she planned a big loan exhibition that's at the Clark Institute called Fragile Beauty. Her current project is a major exhibition on Chinese glass that's scheduled to open at the Corning Museum in 2027. This evening, she's going to talk to us about realgar glass, learning from the archive, the lab, and the hot shop. So welcome, Julie. It's great to have you here with us.
Thank you so much, Deborah. I'd like to thank the Bard Graduate Center for inviting me back, and Andrew for the impeccable coordination. So I'd also like to thank my collaborators on this project, Astrid Van Giffen and Rob Schout, the museum's hot glass team, as well as Karen Stam and Federico Caro for their previous work with me on this subject. What is commonly called realgar glass is an orange and or red glass invented in China in the early 1700s. It was produced at the imperial workshops during most of the 18th century, but the secret to its making was subsequently lost. In this talk, I want to not only tell you everything that we know about this glass because it's fascinating, but I also want to touch on alternate ways of gaining knowledge about a material and the importance of those methods to art historical inquiry. Moving from the archive to the research lab and to the furnace, the approach we've taken so far is a form of technical art history, which combines expertise from conservators and scientists to understand an object's materials and the making process, usually leading to an enhanced art historical interpretation of that object. Taking it one step further is experimental archaeology, a means of testing hypotheses by recreating objects to understand their function or how they were made. Indeed, we've learned a great deal from reconstructing realgar glass. So this project allows us to consider both the laboratory and the hot shop as places of knowledge production, each providing different insights into the special glass and the objects made from it. So I started working on realgar glass, and I will unpack this term for you in just a minute, in 2021 when I joined the Met's Asian Art Department as a postdoctoral fellow. I wanted to investigate the relationship between glass and enamel colorants, and I was able to work with the conservation and scientific research departments to analyze orange-colored objects in the collection. My assumption was that they would share colorants, but in fact, they were completely different. The orange of the enameled peony on the right was created by layering yellow and gold ruby enamels. And the orange glass that we analyzed was, of course, realgar glass. And we found that it was colored using copper oxide, but there still were many unknowns. So when I started my current position at the Corning Museum of Glass, I was thrilled to learn that the museum had been investigating this type of glass for the previous 3 years, and that the research was ongoing. The term realgar-colored glass, or 雄黄色玻璃, connects the mottled and the variegated surface effects of the glass with those of the realgar mineral. But this term was not used to describe this glass at the Qing imperial workshops. The earliest use of the term realgar that I've found to describe this glass is in the catalogue of the 1935 International Exhibition of Chinese Art at the Royal Academy of the Arts in London. The exhibition catalogue lists a glass bowl imitating realgar. In previous discussions of this type of glass, you would find comparisons to tortoiseshell or agate rather than realgar. So the association with realgar appears to have emerged within the connoisseurial community in the first half of the 20th century. Still, it's a term that I'm using here for convenience purposes. The main source of information on craft production in the Qing dynasty are the archives of the imperial workshops, which include highly detailed records of imperial production. The first imperial glass house was established in Beijing in 1696 under the Kangxi Emperor, but workshop archives were only systematically compiled starting in 1723 under his successor, the Yongzheng Emperor. So we have a gap there, right in those crucial years where the first realgar objects were probably created. The archives are organized by date and workshop, with straightforward descriptions of each commission, as well as production notes chronicling the results. The best match within those archives that I could find was the term persimmon glass, 石黄玻璃, which better describes the monochrome opaque orange color of early imperial versions of this glass. The earliest record using the term persimmon glass dates to 1726, as part of an imperial order for bronze spoons to be paired with glass water containers in several colors, including persimmon, as well as snuff bottles of all colors. And by the way, snuff bottles are by far the most common realgar glass vessels surviving today. A subsequent order for a persimmon glass bowl was filed in September 1733. And then during the Qianlong period, production of persimmon glass increased substantially, with commissions recorded throughout the reign, but with a clear concentration in the 1740s. Among these, a series of orders for persimmon glass bottles for holding incense tools, as part of sets also comprising an incense burner and an incense box, appears to correspond to existing objects, such as a small orange vase in the collection of the Metropolitan Museum of Art. So this type of small work continued to be produced in the imperial glass workshops during the Qianlong period, as is the case for the incense burner, also in that collection. Although these archives contain a wealth of information on commissions of glass objects, there's virtually no mention of recipes or detailed making processes. For glass and for several other types of material, what was produced was more important than how it was produced. For instance, a typical entry might mention that and this is how they go, on a 21st day of the second month of the 7th year of the Qianlong reign, which is equivalent to March 27, 1742, a palace eunuch handed over to the glass workshop a persimmon glass vase for holding incense implements, and that just over a month later, a matching incense box was collected. So what took place at the glass workshop during that month exactly remains absent from the written record. The workshop officials wrote for the emperor and for his administration, not for the artisans and the craftspeople, who would have instead learned their craft through apprenticeship by making and doing. I should also note that it's still unclear if there's an evolution from monochrome orange persimmon objects to the more mottled realgar-like objects, or if both were produced concurrently. The earliest objects with imperial marks are from the Yongzheng period, like the small persimmon-colored vase from the Met. However, this pair of more realgar-like vases were collected by Sir Hans Sloane by the 1720s, so earlier than the persimmon examples, and they don't have an imperial mark. So Could the differences be explained by a developmental sequence at the imperial workshops, where realgar colors were favored until the Yongzheng period, where persimmon was favored, and then realgar came back? Or were the different colors initially created in imperial and non-imperial settings? So this is still an area that requires research. So faced with this kind of lack of textual information, our team turned to objects. It was clear that scientific testing would be required to understand the composition of the persimmon and realgar-colored glass objects in the CMOG collection. So our first step was to carefully examine each object to see what it could tell us about how it was made. From this, we learned that objects were often mold blown, as evidenced by the presence of seam lines. And you can see some seam lines on this object right around the front of that shot. The vase on the right also, the vase on the right shows color variations also that indicate the use of an elaborately decorated mold. So we also noted that transparent red areas were thinner than opaque orange areas. So for instance, here you have a very thin layer of red. This layer was sometimes carved like a cameo, as in the snuff bottle in the middle right here. And all of them were polished once cooled. So the snuff bottle in the middle left here could have originally had a red outer layer that was polished, and the bottle was carved into facets. So our conservator had already analyzed our objects using portable X-ray fluorescence, a non-destructive method. XRF is a great place to start when identifying a glass composition, but it has limitations because it cannot detect lighter elements like sodium or boron, which are often the main ingredients in glass. Like our results at the Met, CMOG's results showed that the various colors all had essentially the same composition, with copper as the main colorant, but could not explain how the different colors were formed. Luckily, the presence of a broken snuff bottle in our collection enabled more extensive scientific analyses to better understand the color variations in the glass. These analyses included microscale XRF, X-ray diffraction, electron microprobe analysis, and scanning transmission electron microscopy. They were done with our partners at Corning Incorporated. So Corning Incorporated is a company specializing in advanced glass and ceramic technologies, separate from the museum, but headquartered in Corning, where their research and development labs are also located. So our team tested the yellow and the orange/brown and red portions of the glass. The testing produced a complete quantitative composition for the glass. So as you can see, there's about 56% silica, 23% boron, and then smaller amounts of sodium, arsenic, and copper. The coloring agent in all colors was copper-1 oxide in the form of cuprite crystals. So this begs the question, how do crystals affect color? Well, the smaller crystals let light through, leading to the transparent red glass. The larger crystals scatter more light, increasing the opacity of the glass. So let me just say that another way. The colors are not created by different colorants, but by different sizes of copper crystals. So we had reached the limit of what we could explain with chemical analyses. And to put our hypothesis to the test, we would need to recreate that glass. So I'm now playing a 3-minute video by Corning Incorporated showing how they batched realgar glass by combining all of the ingredients that you saw on that table together, mixing them and putting them in a crucible to melt in a furnace. While they do that, I'll keep talking. So fortunately, modern technical glass batching labs have access to a wide variety of raw materials, featuring nearly every element on the periodic table. After considering the raw materials typically used, so sand, borax, copper oxide, arsenic oxide, limestone, and soda ash, and their appropriate ratios, they calculated a batch that would yield the corresponding glass chemistry after the high temperature melting reactions. Individual raw materials were weighed, combined, and mixed thoroughly before being placed in a crucible for melting. The glass composition is very interesting to the scientific community working in the glass industry for two reasons. First, modern glass science history, which has traditionally focused on Western glassmaking, posits that three German chemists were the first to introduce boron oxide to glass in the late 1800s. So supposedly all glasses prior to this period were traditional soda lime silicate glasses, and their introduction of boron led to the creation of low expansion glasses for microscope and telescope lenses, and ultimately to the heat-resistant borosilicate glass that we now know as Pyrex, which contains about 13% boron. But these 18th century realgar glass artifacts contain about 20% boron oxide, indicating that boron was intentionally sourced and added to the formulation. This is the mixer, you see, it's great. So, realgar glass contains more boron than Pyrex, which completely undercuts the history of modern glass chemistry. Anecdotally, the composition of realgar glass was so surprising to Rob Shout, our glass scientist, that he described it as being out in La La Land compared to the glasses that he's used to working with. In addition, boron is a relatively rare element on Earth and is mined in only a few locations worldwide. The fact that the Qing dynasty could source this rare element for glass melting in high volumes is remarkable and shows advanced knowledge about the origins and value of boron-containing minerals. The second thing we learned from this composition or recipe is that realgar glasses contain a high concentration of arsenic oxide, about 4 to 5%. This oxide does not contribute to the coloration itself, but it likely provides reducing power, meaning that it keeps copper dissolved in the melt and favors the red coloration instead of the more oxidized copper that would typically yield a blue-green color. Without arsenic, these realgar glasses would yield a more greenish coloration. So, as with boron, the high arsenic used in these glasses speak to an ability to source individual raw materials and understand their importance to the glass batch. Then, the crucible containing the well-mixed raw materials was heated in an electric furnace to melt it to a liquid. A temperature of 1300 Celsius created a well-mixed and fully melted liquid, and that took a little bit of experimentation to figure out the right temperature. Pouring this melt onto a steel table produced a high-quality slab, which was subsequently annealed, which just means it's cooled down very slowly. So you will see them taking that very hot crucible out of the furnace and pouring the glass onto that steel table. And just a few seconds later, the glass is cool enough to handle. Obviously not to touch, but and then it's cooled down in a separate oven that will take it down to a normal temperature. This is what we got. At room temperature, the variation in glass color became visible. So this is a piece that was cut from one of those slabs that were poured on the steel table. The area of the glass that touched the table first cooled very quickly, and that's what you can see on the top there. And it produced that characteristic red layer and the mottled patterns. The part of the glass that cooled more slowly formed an opaque persimmon layer. It was amazing to us that just rebatching the glass and pouring it into a slab would create such successful results, matching the range of colors present in the historical objects. But a slab is a little bit easier to make than a vase. So how did Qing Dynasty glassmakers shape this material and manipulate the size of the crystals to create patterns and colors? Achieving the right coloration in the glass that was batched, melted, and poured at Corning Incorporated confirmed that the glass chemistry was correct. We also knew that heating and cooling were key to controlling the color. We wanted to understand how objects were formed at the furnace. So Corning donated several pounds of glass-colored to the museum, and we then enlisted the help of the museum's hot glass team, who typically perform glass-making demonstrations for the public. They also regularly work with guest artists, and they are the A-team on every season finale of Blown Away, for those who watch. Glassblowers from the hot glass team were unaccustomed to working with this type of glass, and their insights were really quite invaluable to understanding how its working properties compare to modern glasses. In the spring and summer of 2023, they had already built a fully functional wood-burning furnace in the museum's courtyard hot shop. The furnace was initially constructed to support our special exhibition, Dig Deeper, Discovering an Ancient Glass Workshop, which explored 4th century glass production in the Mediterranean. But we took advantage of that furnace to melt some realgar glass. So on a warm July morning, the team stoked the fire and melted the realgar glass in a crucible at the heart of the furnace. And it took about 6 hours for the furnace to reach the right temperature. And someone was stoking it consistently all that time, woke up at 5 a.m. to do it. We wanted to know if the glass could be melted and formed at a slightly lower and more variable temperatures afforded by this type of fuel, as opposed to the modern gas furnaces that are used in the hot shops today. Since imperial workshop records mention the use of firewood and coal in glass furnaces in the Qianlong period. We also wanted to test a few mold materials, such as wood, ceramic, and steel, to see whether their different rates of heat absorption would have any noticeable effects on the coloration and patterning of the glass.
That's great. That's really good.
Here you can see Jeff Mack working with this glass for the very first time. Just looking at it with suspicion. He's taking a second gather to have a little bit more glass on the end of his blowpipe. And those of you who've seen a gas furnace will know that you don't normally have a flame coming out of the furnace. This is because of the actual fire going on. So he's shaping that gather, and then he'll blow it slightly. And someone just outside the frame is ready with a mold. We'll be trying out that mold.
Why don't you go down? So I can. It doesn't matter. I forgot. The blowpipe's the only way through. Go ahead. Close it. Close it. Close it.
Go down. Go down.
That was a little bit messy, but we still got an object.
Sort of. Boy, that stuff is long.
Okay, so I don't know if you caught that, but he said that stuff is long. He's also said that it was much runnier, and I think that's what he means with it, and harder to control than the soda lime glasses that the team typically uses for demonstrations. So it got more viscous, it was more honey-like, more quickly than the normal glass, and yeah. And it also, he said that you could work it a little bit longer than the soda lime glass until you had to reheat it again. So there was a learning curve there. And these are some of the objects that were made in this first experiment at the wood burning furnace. We can see some of the translucent red coming through, but the opaque orange isn't quite formed and it's a little bit more brownish. I have one of these samples today if you want to take a look at the end. And some of them have been polished or cut to see inside. So actually this flared dish is a little bit more orange inside, less greenish. The team further found that polishing and carving, which is known as cold working in the glass world, was key to revealing the colors and patterns of the glass. So Jesse Racide, who did this, he's our hot glass program senior technician. He noted that when cold working, the glass felt similar to modern glass, but it had a tendency to chip and flake apart at the edges when it was cut. Experimenting with different kinds of glass led to many insights into its working properties when hot and cold, but the precise effects of mold materials are still to be determined at this point. So a second round of experiments, this time in a modern glass furnace, I keep saying glass, but it's gas furnace, considered the importance of thermal variation in the creation of an opaque persimmon core and a translucent red overlayer. Importantly, the gas furnace gave us much more control over the temperature ranges, hence the better result here. It's a good indication of how skilled Chinese glassmakers were, that they could really create high quality objects from wood and coal burning furnaces. So, building on the prior observation that copper oxide crystals were responsible for coloration, we, or I should say Rob, hypothesized that they would nucleate and grow at different temperatures like modern glass ceramic materials. We found that samples of glass that had been rapidly cooled to minimize growth of the copper crystals were dark, translucent, and ruby red. And when these glasses were reheated to softening temperatures, the crystals grew larger and the material became opaque, and the color shifted towards that orange persimmon. So we identified that the glass required a heat treatment between 600 and 700 degrees Celsius for 5 to 15 minutes to allow those orange crystals to grow. And at these temperatures, the glass is viscous enough to retain its shape while allowing its atoms to move and rearrange themselves into larger crystals. So this enabled the glassmaker to control whether the glass was in either of these states, translucent red or opaque persimmon. So we finally achieved a good layering of colors, and the best way I can explain the heat treatment that the glass needs to undergo to create these colors is to compare it to tempering chocolate. If you watch the Great British Bake Off, you will know that the contestants wrestle with this all the time. The chocolate needs to be slowly heated up to a precise temperature, cooled to a lower temperature, and sometimes, depending on the method, reheated to a middling temperature before it can finally gain that satisfying sheen and the snappy texture. So our experiments revealed that realgar glass needs to be tempered in a similar way. The molten gather would be formed to the desired shape first using a variety of molds and tools, and then still attached to the pipe, the glass object would be parked. We said it was parked in a furnace at constant temperature to allow time for the crystals to grow. And then that temperature is hotter than annealing, but below the temperature at which the glass flows rapidly. And then if the process stopped there, you would have an opaque persimmon object. And in certain cases, the object's surface would then have been rapidly reheated or flashed to melt back the copper crystals on the surface and quench to lock in that translucent red coloration to create that red outer layer. And this is one of the first test pieces at the gas furnace, and you can see started at 1400 degrees, parked it at 980, and then annealed at room temperature. And you're getting a little bit of persimmon core, but not really that red outer layer. So that was not quite the right combination of temperatures. I can't remember the combination of temperatures for this one, don't ask me. Rob has them. So this specific thermal history is needed to create the layering of translucent red on top of an opaque persimmon core. This round of experiments successfully resulted in objects with a persimmon core and red outer layer made more visible when the object is ground and polished. So the complexity of the heat treatment required to create these colored layers from a single glass composition demonstrates that the original makers had deep knowledge of the material's behavior. The creation of vessels with this, the solid persimmon and the layered colorations would have required either multiple furnaces operating at different temperatures or the ability to rapidly adjust the temperature during the process of making a single vessel. So these experiments are still ongoing. We initially focused on heat variations and some mold materials, but next we'd like to explore another body of realgar glass objects that feature pictorial patterns. Here you can see two types of vases, one with line patterns of a dragon in clouds on the left, and the other with floral decoration. Because of seam lines on both objects, as you can see a seam line here and another one on the edge of the object here, it is clear that these patterns were created by molding. You can also see that the orange line patterns and the red background are flush with each other. So after molding, the surface of the vessels was evenly polished, revealing the orange underlayer. We've already experimented with melting the glass onto an irregular surface. To show the effect of this molding method, the glass was cut in half and one half was polished. So you can see that where the glass entered the mold and became convex, those were the areas that were polished down, revealing an orange core. This glass is really incredible. Like, I don't know of any other way to use a mold to create a pictorial pattern that's flush with the surface. So, in the next few months, we want to extend our understanding of surface effects by using a newly commissioned custom mold to clarify how convex or concave surface designs in the mold impact the coloration of the pattern after the piece is polished. So this is a solid bronze mold that I brought today. I hope you have a look at it after the talk. And I'm happy to speak more about it and also the samples. This project really played to the museum's unique strengths, namely its encyclopedic collection, expertise in various aspects of glass history and making, and a long-standing partnership with Corning scientists. As we plan to disseminate these findings in the museum's physical display spaces and online platforms, questions remain as to how to best convey the making process to an audience that is largely unfamiliar with glassmaking, let alone realgar glass. How can we make these recreations more visible to museum visitors? We have been documenting the process by keeping samples from various stages and also thinking about using these test pieces for a step-by-step display in a gallery setting. We've also been filming key moments, as you saw, and we hope to create either a short gallery video or a longer film that would be available online. Reconnecting with ancient craft practices through object displays and digital media is a promising way to get museum visitors engaged with these objects when they're on view. More generally, this project has shown that reconstruction can be key to understanding objects, especially their material composition and how they were created. Recognizing the unique characteristics and behavior of realgar glass relied on a range of expertise, including that of conservators, art historians, scientists, and makers. By moving through this process, our team members broke down some barriers between disciplines and arrived at a fuller understanding of a specific material. Thank you.
We have time for some questions. Would you mind passing that down?
Thank you so much, Julie, for a fascinating talk. I was literally just glued to the screen and to your words. You mentioned in the sort of first few minutes of your talk that there were comparisons made, I think, in the late 19th century and 20th century with agate and other sort of hard stones. And I'm wondering if we have any information on the reasons why this sort of glass was invented in the first place. Was it as a means to imitate hard stones, agate and precious stones? I mean, it seems like there's sort of an obvious connection there, but I'd love to hear more about that.
Yeah, that's a good question. We don't know why it was invented in the first place. It could have been an accident, and then, that accident was built upon to refine the properties of the material. Because we just don't have archival information for that portion of time when it was likely invented. A lot of glass at the Qing court was used in ways that imitate other materials. So as you can see on this display, you'll have glass that looks like, enameled, opaque glass that is meant to look like enameled porcelain. You'll have the realgar glass that is either looking like persimmon or like the mineral. And then you have some bean green glass that looks like glazed ceramics again. And this one also looks like the turquoise mineral. So there was a lot of playfulness about, imitating other materials at this time, whether it's in ceramic, it's in enamel decoration, or it's in glass, or even other materials. You see imitations of coral or wood or other stones all the time. I don't know if that's how it was invented in the first place, but it's definitely in the mindset of that era.
Hi, what was the temperature difference between the gas furnace that you started with and the wood burning furnace? And how did you control the temperature in the wood burning furnace?
Yeah, good question. I'm not the best person to answer this question, but we had a thermometer on the wood burning furnace to tell us exactly what the temperature was. And I think we did reach 1300 Celsius, which was the temperature needed for the red glass to occur. But I think our control over the temperature variations was not there. So, maybe that's why the samples were not all of that successful. What was the second part of your question? I'm sorry.
So the first one, just the difference between the gas furnace that you
And
traditionally used and then the wood burning.
right. So wood burning is typically a little bit lower, but we achieved those high temperatures that we needed. And how the second part was how do you control? And it has to do with stoking the surface, the furnace in a specific way. More wood, but not too much to suffocate it. And we're able to, to get it high really quickly and then slowly bring it down. But I guess it wasn't slow enough, or we couldn't reach those lower temperatures fast enough when working with the material. So that has to be adjusted. Yeah.
Hi, is realgar glass, is it defined by this specific palette? I've seen other things identified as realgar glass that are sort of like a red and black. Is that a misattribution or?
Yeah, the British Museum, I think, has a set of little wine cups that are more red black. But I think that is the black is actually the green of the copper kind of oxidizing to black.
So it's generally this sort of persimmon. Okay,
Yeah.
thank you.
Yeah, sure.
Thank you so much. This was so fascinating. I love the process of talking about the archive to the lab to the hot shop. And I'm wondering if it's changed your perspective in returning to the archive after that process and if you figured out anything new, whether about this material in particular or something different that you're working on. And also, just as a second question, I'm curious about how often the museum does these sort of experimental demos and like where they're trying to go with that approach, because I feel like as a visitor it seems like the most exciting thing to see like how we're recreating the past. And so I'm just curious like what the next steps are in terms of like showing that to museum visitors.
Yeah, well, we have demonstrations, I think it's 8 times a day. So the hot glass team is always doing demos at the museum. But they have yet to do a realgar glass demo because we have so little of the glass. But that would be interesting. As Deborah alluded to, I'm working on an exhibition of Chinese glass at the museum, so that will probably be part of the programming for that show. And about returning to the archive, to be honest with you, I haven't returned to the archive in a while. But yeah, I think it would color my interpretation a little bit, and I would be looking more for the blank spaces rather than what's there. I would be wondering a little bit more about what's not told. Yeah. Sure.
Hi, I have two quick questions. One is about arsenic.
Okay.
Because you had the chance to look at other glasses, they all have arsenic, or you find others with lead, let's say, and why, if there's any speculation about why arsenic rather than, let's say, lead instead.
Yeah, they all seem to have the general composition, but I think the one that we looked at had a little bit more iron. So they do have different the different mixtures. And Bristol Art Galleries and Museum also analyzed one of their realgar glass pieces that's a little bit more persimmon, and it had completely different ratios also. So all of this analysis is from one snuff bottle in the collection. So that's only one recipe. So
Okay.
yeah, a lot of the interpretation is based on this one sample.
And the second one is about parallels in other cultures, and I wonder if you thought about any correlation between this type of glass and like Roman tesserae, which might show the same type of variation.
Yeah, I haven't looked at that further. It is interesting to look at red and orange glasses in different contexts, because China is not the only one to have created this color of glass, but we would have to, compare some of those compositions. There was also brownish, orangey glass produced in Europe around the same time, so more to be learned about this.
Great. Any other questions?
Going from glass to crockery, the vase in the center of this shot and also featured on the intro to this lecture was the Art Nouveau. It looks like crockery. It might have influenced crockery from before the First and after the Second, before the First World War and after the First World War. Is there any background to this that Art Nouveau crockery might be influenced by such things?
I'm not sure about realgar glass, but there might have been some Chinese and Japanese objects that reached some of those designers and gave them inspiration, but I don't know about realgar glass.
Got a question, right?
Hi, Julie.
Hi.
Really interesting talk. I was in cross section. It looked like the outer dark or the red transparent glass. There was a real definite transition between that and the more orangey yellow. And is that true when I'm seeing? I was struck that it wasn't gradual, but it was a real red strip, and then because I know when we were looking at the sensor, which was layered, I was thinking I was seeing the darker red towards the inside with a gradual transition to the more yellow, and then I'm thinking, well, maybe I was just didn't know what I was seeing. So I found that really interesting, and I was wondering if you could comment on that, and also just the layering that we saw in.
I think we're still a little bit stumped about that, to be honest. So what Karen is referring to is when you look at the cross section of this particular object, you have beautiful gradients that are from red or from I think it's more dark orange to yellow. So how those were created, to me, is still a bit of a mystery, to be honest. Yeah, but it's not. I don't think this is going all the way to red. It's still within that persimmon range of orange and yellow. So I don't know, but it's beautiful, and it's my favorite object.
Any other questions? Then please join me in thanking Julie Bellemare.
Thank you.